This video will walk through the solutions of the tasks from the Week 1 notebook for the Cross Society Python course. Let's start with task 0, which asks us to figure out how to get the cell to display a better food, just going between the string and typing out a better food. So for example, I might say, I like chocolate. So there we go, I love chocolate. Nice and easy. The first proper set of tasks happen after operations, and so here you can see the first task is about determining what a script is going to output before it actually does so. So let's walk it through. So we see that best is 5 and worst is 2, and OK is best plus worst. So OK will be assigned to 7. So then we print OK, which is going to be 7. Then you can see that worst, or the new value of worst, is going to be the old value of worst minus best. So currently they're the same, so it will be 2 minus 5, so the new value of worst will be minus 3. When we print out, we're not actually printing out this new variable, we're just printing out best and OK. And we know what best and OK are already. We know that best is 5, and we just printed it out a second ago. We know that OK is 7. Finally, we set OK to be best times worst minus OK. Because of how operator precedence works, you can see that best times worst is going to happen first. The current value of worst is minus 3, so best times worst, that's minus 15 minus 7, which is minus 22. Worst is what it was before, so that's 7. And finally, OK is minus 22. So it should print out like that. And there we go. Task 2 asks us to find out what this script does. So if we just run it, we can see that at first it prints out 7.3, and then it prints out 3.7. So we call this before and after. So something's happening in the middle. Now, you might notice that it seems like the values of goose and duck have been swapped. Let's test our hypothesis. Let's try 2 other values and see if that's still the case. So if I try 10 and I try minus 7, let's see if that still works. And yes it does. So it does appear like these values are being swapped. And yes, in fact, this script is swapping the values. In practice, you wouldn't swap variables like this. You would instead do something like this. So goose, duck is equal to duck, goose, which is probably one of the more concise ways to write it. For task 3, this script isn't quite right. So it's supposed to convert kilometers into miles, but if you actually run it, it doesn't quite work. So it turns it into 0 for some reason. And the reason for that is to do with this division. So this is a floor division, so it will round down to the nearest integer. In this case, we want our result to be a fraction, so if we just remove it like this, then we get the correct answer. Task 4 asks us to write our first proper program. So we just have to declare 2 variables. So firstly, radius. So let's set that to be some value, some number. So I'll say it's 7. Let's have pi be roughly 3.14159. You know, you get the idea. So it's fairly accurate. And now let's calculate the area. So the area is defined as pi times the radius squared. So the radius times the radius again. And then finally, we need to output the area. So let's print the area. And if we run that, we get a nice result. And you can verify that that's correct. For task 5, we have scripts that aren't quite correct, and we have to figure out why before running them. So, in fact, the syntax checker over here is already doing a lot of the work for me. If I hover over, it will tell me that, something isn't quite right. And you can see that this is because our name should be on the left side, not the right side. So this is the reason why the script doesn't work. For the second one, it's a bit more subtle. So this line here actually runs perfectly fine. The white space does not matter. But this line here is where the problem happens. And that's because of the plus equals operator. Now, the plus equals operator is equivalent to doing this. We are adding 2 to a variable that doesn't exist yet. So it will give us a name error. Finally, the third script fails for a different reason. So you can see again that the white space does not matter here, so that will be fine. But you can see that here will cause a problem, because here we're dividing by 0, and we'll get a 0 division error. Task 6 asked us to modify only line 1 of the following script to cause an exception on line 4. Now, you can see here how we're going to cause an exception on line 4. The other way we can think about doing it right now is to cause a division by 0, right? So we need to make sure that a is 0 by the time we get there. So, working backwards, we can see that a subtracts b from itself. So we need a to equal b for this to work. So, b is 6 times 5, so a should be 30. And there we go. The string section is fairly hands-on. So in task 7, we're asked to try a bunch of different things. So we're asked to add two strings together, which we can do by just running the cell, and you can see that they concatenate together. Note that because there's no space in the strings themselves, there's no space here. When we try to multiply two strings together, this just causes an error. When we try to add a string and an integer, so just let me go plus 6, you can see that this is going to cause another error. But when we times a string and an integer together, it actually repeats the string that many times. This task is probably one of the first tricky ones, so it asks you to display the following text all on the same line, exactly as it's written. Now, the text contains both double quotes and single quotes, which, with the knowledge that we know now, makes it hard to do on one string. So we can use multiple strings and concatenate them together. Let's create these different strings and bring them all together. Okay, and if we run that, we can see that there's a slight issue, and that's that this is not separated. So if we just add another space, we get the right output. Task 9 is fairly simple, and just asks us to put a /n in the middle of the string. So I do it here, and I run it. You can see that it actually prints a new line, so we immediately go on to the next line here, no matter where we put it. Task 10 is a fairly long description, but we're basically asking to replace the to Adam here with a student name variable that we can then substitute in Adam, or any other student that we would like to give a report for. So, firstly, let's uncomment this, and type in Adam. Now we're going to replace Adam with student name everywhere we can. And there we go. This exercise is to try and get you used to making sure that there's spaces between each of the words. Now we have the exercises on typecasting. So for task 11, we have to try and correctly display this sentence. So first, let's type in 8 pence. So first, let's add the number of pence. Here we have to use the cast, so we're casting it to a string, and that's the integer here. Next, we don't need to cast this because it's already a string. And then finally, we need to cast this again, but again, it's to a string because we're converting to a string, even though it is a float. There is one more bit, and it's saying that this is the total stock of how many sellable products we are. Now, for neatness, it would make sense to create a total variable. So the total is the pens plus the pineapples plus the apples. Oh, but there's a slight problem. So you can see that the apples here, firstly, the pineapples is a string. So we need to convert that to an integer to be able to add them. And then we also need to convert the apples slightly. So we're rounding down in order to get rid of the half an apple, which is probably not suitable to be sold. And just fix up the... There we go. So that's the exercise. Now, this task you might have finished quite quickly, and that is if you run the script. You might have tried in a few more variables, so I might have tried 9 and say 4. In fact, let's keep it at 4. And you can see that we've got the same answer. However, where it breaks down is when we have negative numbers. So if I put in -9 here, then we will get two different answers, -2 and -3. This is because integer always just chops off the end decimal places, whereas x into division y always rounds down. So they're not quite the same. This is probably the hardest task, and it's about determining if any of these scripts will run, and if so, what they will output. So, for script A, this is something that's quite interesting. If you run this, the conversion does not work. This is because when you're trying to convert a string to an integer, it individually checks each of the characters. So it goes, is this a digit? Is this a digit? Is this a digit? Oh, well, this is not a digit, so the conversion fails. You could also have a minus in front of here, but you cannot have a decimal point when you're trying to convert to an integer from a string. For script B, we can see we have 5 here. We're turning it into a string, appending the minus character back to an integer, so that becomes -5. And then for minus, we're turning it into a string, so -5. We're turning it to -5, converting that back to an integer and printing it out. And here's the problem. So, as you can see, it says that you cannot convert minus minus 5 into an integer. And again, this is to do with the way that the int conversion algorithm works. So, minus minus 5 is not a number, 5 is a number. For script C, if you do all the conversions, you might be forgiven into thinking that this will do a division by 0. However, because this is a minus equals, and we are minusing minus 100, this then becomes 200. So A is 200. And then when we do the division, we actually get 0.5, not 0. This one is actually the same as script A, but it's slightly hidden. So when we run it, we can see that it's trying to convert 4.0 into an integer, the string 4.0. And this conversion happens fine. When it's converted into a float, so rainbow becomes 4.0, and then we convert that into a string, we try to int it, and this is where the problem happens. And finally for script E, so we have 7, the name 7 is equal to the string 4, and the name 4 is equal to the string 7, and then we do a bunch of operations. This first one is something we encountered earlier. It's what happens when you times an integer and a string. We get that many copies of the string all concatenated together. So that works fine. We also have, so we're converting, so these are all strings already, so this will be a string that itself can be turned into a float, and it is. And then finally, we convert this to an integer, and then add it to a floating point number. And because of type widening, this also works. So when we print this out, we get the following. The final exercise is to write a script that calculates the area and perimeter of a rectangle. So firstly, we need to start with the input. So let's get the length, and that's equal to the int of the input of, say, enter length, for example. Then we go width, and that's equal to int of the input of enter width. I mean, it doesn't really matter which order you put these in, because again, it is the same. And then finally, we do the area, that's the length times the width. And then we also know that the perimeter is 2 times the length plus the width. And then finally, we can output both. So we say print the area is length plus this needs to be the string of the area, and then that is and the perimeter is, and then string of the perimeter, and that should hopefully work. So let's enter our length. Let's say that it's 4. Let's say that the width is 5, and the area is 20. Yes, and the perimeter is 18. Also yes. Nice. Finally, let's discuss the bonus tasks, which are more challenging. This one actually only needs some of the knowledge from the earlier sections. Firstly, we need to figure out the total number of slices, and there's a hint there for you. So, the slices we'll need to order in total is the amount of slices per person times by the family size. So let's just do that real quick. So slices needed is equal to family size times slices per person. Now, you might think that we can just do the number of pizzas is equal to, firstly, the slices needed, and then we divide that by the number of slices per pizza. However, when we print that out, it doesn't always work. We need to make sure that each family member has at least 2 slices per person, but this actually leaves us a few short. Here, we're rounding down on the number of pizzas, but instead we should be rounding up. There are a few ways to fix this. The one that I personally prefer is to do this. So what this does is it shifts things along such that the floor is equivalent to what we call a ceiling, so it will round up. This is quite tricky to spot, so well done if you got this. Another way that I saw some people doing was taking advantage of the result of task 12 and using a minus combined with another minus to make it round up instead of down. Also, don't forget to add the number of slices that we left over. After introducing the min and max functions, we then ask, how do you get the middle number of 3 numbers? Firstly, it would be helpful to get the minimum and also the maximum number. Now that we have these, we just need to get the total of the three numbers. And then finally, we can just take the 2 away. And there we go. Another way to do it is by taking the maximum of the minimum of each pair of numbers. This would also work for strings. This challenge asks us to find out which of these three strings are the greatest. And here you can see that the string computing is the greatest. But why is this the case? One answer you might think is the length. However, if I shorten down computing to just be com, then it is not the greatest in terms of length, but it is the greatest in terms of alphabetical ordering. So it is further down the alphabet than the other three strings. If I then change coding to zoding, then you would see that zoding is then the greatest. For this challenge, we introduced the square root function from the math library and the pi constant. So if I press play, you can see that this gives us a value of pi already. Firstly, we need to get the area of a semicircle. So let's do that. In order to work out the perimeter, we first need to work out the radius. You were of course free to look things up for this challenge, so you would be able to figure out how to get the radius from the area. In fact, I would probably want this to be a float, not an int. The perimeter would then be as follows. So usually it's pi times the diameter. However, we also have a flat section here. So it would be pi times the diameter, that's 2 times the radius. But that's divided by 2, so we don't need to make this. And then we add on the diameter. So this is 2 times the radius. And if we run this, and enter about 2 pi, so let's say 6.3, we run this, we should get 5.14, which is approximately 2 plus pi. Slight mistake there, that should be area times 2 over pi for the radius squared, otherwise it gives you the wrong answer. Challenge 5 asks us to write a script that finds the distance between two coordinates, x1, y1, and x2, y2. This script takes the maximum of the two differences, and then finds the distance between them by squaring and adding, and then square rooting. We can slightly simplify this by using the abs function, or absolute value. However, watch out, I haven't actually converted these inputs into floats, so I will do that now. To make sure this works, I'll use the classic 3, 4, 5 example. So if I enter 0 here, 0 here, 3 here, and 4 here, the answer should be 5. And indeed, it is. Those were all the solutions for this week. Hopefully you found this video helpful, and if you'd like to ask any more questions, feel free to join our Discord.